Good afternoon, engineers. We are going to continue going over the test solutions. So we are on question 2, Roman numeral 2, which says evaluate the integral of 1 over the square root of 4 plus x squared to the power 3. So in the other question, we have to figure out what we're going to use, but then in this question, we're being given a hint. We are being given a hint to say use trig sub. So you don't have to check out how or which rule we are going to use. So we're going to use trig substitution, and then we know that in trig substitution, when we have got something like a squared plus x squared, we're going to let x equal to a tan theta, so that when you put it there, they can square each other. So now when you compare these, you're going to see that a is just equal to 2, so that 2 to the power 2 will give us 4. So then let me just box this because it's not part of our solutions anyway. So in this one, you are going to see that we'll have to let x equal to 2 tan theta. So now we're being given the integral of 1 over the square root of 4 plus, now where there is x, we'll put 2 tan theta, but then remember x is squared, and then the whole of this is cubed to dx. Never forget the variable of integration dx. So now this one is with respect to dx, so you can change it and put it with respect to theta, so that later on we can evaluate this one by saying dx over d theta is equal to, so we're going to use dx over d theta so that we can relate dx and d theta, and then we're going to switch them where we'll let dx subject of the formula, and then we're going to replace where there is dx, we're going to put whatever will be this side, and then it will have a d theta. So now we have got our variable of integration changing. So dx over d theta, so that's this one over d theta, is simply 2. The derivative of tan is sec squared theta, and then if you have problems with derivatives of trig functions, I've made a video about them. So you will now make x a subject of the formula. We are going to say dx is equal to 2 sec squared theta d theta. So now we're going to have our 4 in the square root, in the brackets as well, 2 to the power 2, that's 4, tan to the power 2, tan theta to the power 2 is just tan squared theta. All of this is to the power 3. Then where there is dx, we can put 2 sec squared theta d theta. So now when you multiply this one, they are going to have 2 sec squared theta. Then in the denominator now you can factor out the 4, then you have 1 plus tan squared theta to the power 3 d theta. So now we're going to have this 4. This 4 is being affected by a square root and also the cube. This 2 is just the way it is, so you can push a 2 out. But then this 4, we're going to say a square root of 4 to the power 3, so that this one can be factored out. Or you might as well just let me write it there. You might as well just write the 4 there. Like, you find the square root of 4, which is 2, then take it to the power 3, which is 8, which will give us 2 over 8, which will still come back to 1 over 4. And then when we try to go on further, we're going to find that all that we're going to get is 1 over 4. So now we have got sec squared theta on the top, then on the bottom we have the square root of 1 plus tan squared theta to the power 3 d theta. So now this is why many people find it a challenge, because when substituting the trig functions, you don't know which one to evaluate here. You don't know what 1 plus tan theta is equal to. But then there is a trick that I use. I first start with what I know, which is sine squared theta plus cos squared theta is equal to 1. So now what I would do is I will divide both sides of the equation by something so that I can have tan theta. So now here, for me to have tan theta, I'll have to divide all sides by cos squared theta. So when I divide by cos squared theta, cos squared theta, cos squared theta, this one I'll have tan squared theta. Here I have my tan squared theta. Then this one will be 1. Cosine squared theta over cosine squared theta is just equal to 1. Then 1 over cosine squared theta is equal to sec squared theta. So now here we have tan theta plus 1, which is equal to sec squared theta, which can be put in there. So I've done a video on how you can try to derive the ones for substituting, where if you have maybe sec squared theta plus something or plus 1, you can just try to come from this one and then go to whatever you want to have, because it's very, very hard to memorize this. But then if you have a method that you can use to derive this one, it will actually help you in many, many ways. So now we replace sec squared theta there. So we'll have 2 over the square root of 4 is 2 to the power 3. We have sec squared theta over the square root of sec squared theta to the power 3. So now the square root of sec squared theta is just sec theta, and this one we have got 2 to the power 1 and 2 to the power 3, so you can cancel this one out, so that you can have 2 to the power 2 over the square root of sec squared theta over this one will be sec theta. Then when you take it to the power 3, it will be sec 3 theta. Then this one is just simply 1 over 4 square root of 1 over sec theta, because these ones will cancel and these ones will cancel. Then remember, we're integrating with respect to theta, so there we have our d. So now we can get another sheet of paper. Then we can now start from where we ended. We have 1 over 4 sec 1 over sec theta d theta. Yeah. So now this one is the same as 1 over 4 sec what the inverse, the 1 over cos theta is the same as sec theta. So 1 over sec theta is the same as cos theta. So this one it will just be cos theta, because 1 over cos theta is equal to sec theta. So now when you try to cross multiply there, when you try to make cos theta a subject of the formula, you're going to have cos theta sec theta equal to 1. Then cos theta, when you divide both sides by sec theta over sec theta, you're going to have cos theta being equal to 1 over sec theta. So now we are trying to find the integral of cosine theta with respect to theta. So this one will just be 1 over 4 with the integral of cosine is just sine theta d theta, sine theta d theta. Then we'll add the sine theta, just sine theta plus c. So we'll add c, the constant of integration. So now we want to go back to x, because we are differentiating with respect to x. So that's how we want to evaluate it, but not with respect to theta. So now then, how do we turn our sine theta into something that has the variable x? Now remember, x here, x is equal to a tan theta. Thus x over a, when you take the a down there, is equal to tan theta. So now what we have to do is change this sine theta into tan theta, or anything that looks like tan theta, maybe cot theta. So at finally we can replace this one, and then while there will be tan theta, we just put x over a. But then in this case our a was 2, so wherever we find tan theta, we'll just put a 2, and then we'll be good to go. So now let's try some of our methods from sine, the one which I showed you earlier, sine squared theta plus cosine squared theta is equal to 1. So what we're trying to look for is something that can have tan and tan and sine, but then when we divide all sides, we'll find that the sine will go. So the best we can do now is try to change this one into 1 over 4. Then this one will be, we'll try to take this one to the denominator again. We'll say times 1 over cosec theta, because this is the same as that. So now we have 1 over 4 cosec theta plus c, and then we can relate cosec theta with tan theta, because remember, when we divide all sides by sine squared theta, so that when we have the 1 over sine squared theta, we have the cosec theta, sine squared theta over sine squared theta over sine squared theta. We'll have this one to be 1 plus this one will be cot squared theta, then this one will be cosec squared theta. Now we have something that looks like tan, because this cot, it has a tan in it, and then we have the cosec there. So all we have to do is make cosec theta subject to the formula by saying cosec theta, when you take the square root of both sides, cosec theta is equal to 1 the square root of 1 plus cot squared theta. And then this is just rough work, you don't have to show it in your working, but then you can take this one back there. So you have 1 over 4 cosec theta is just the square root of 1 plus cot squared theta plus c. So now we try to replace, since tan theta is 1 over cot theta, we can say cot theta will now be equal to x over, will now be equal to 2 over x. So we just flip them, or you can just try to say 1 over 4 square root of 1 plus 1 over tan squared theta plus c, so that you can directly replace them. So now we have 1 4 the square root of 1 plus 1 over tan squared theta is x over 2 squared, because tan theta is x over 2, and then tan squared theta will just be the squared plus c, and then we're going to evaluate, because now we have our x 1 plus this one, the denominator can go up. We are going to say 2 to the power 2 over x to the power 2 plus c. But then you will notice that this is actually the same thing as where there is cot theta, put in 2 over x, because it will be 2 over x to the power 2 and then x to the power 2 as well. So I have the square root of x. X will now be, when you try to add, this one will be over 1, x will be a common denominator, x into 1 into x is just x squared, 1 into x squared, sorry, and then x squared into x squared is just 1, and times 2 to the power 2, which is 4 plus c. So we go on to evaluate this one again. We'll have 4 1 over 4 is in the denominator, 4, then we'll have x squared plus 4 over x squared. Now this square root can be taken just for the denominator and the numerator, because they're the same thing at the end of the day. So now we have 1 over 4 square root of x squared plus 4 over x squared, the square root of x squared is just x, then x is in the denominator, so now we can push it so that it goes to the numerator, or we can try to say 4 the square root of x squared plus 4 divided by this one is the one that will be dividing by x, so say this one divided by x. Then what will happen is we'll change this one to a multiplication sign, then the x will go to the, since it was in the denominator, it will go to the numerator, then it will be on top. So we'll have something like x over 4 the square root of x squared plus 4. Or just from here, this step was just to show you it's I would say unnecessary in your working. From when the x is just in the denominator, you can push it to the numerator. When it's in the denominator of your denominator, you can push it, it goes to the numerator, not just in the denominator. So this one is in the denominator of the denominator, so it goes to the numerator. So now we can conclude to say we started from here. So now I can conclude that therefore 1 over 4 plus x squared to the power 3 dx is equal to x 4 the square root of x squared plus 4 plus c. The answer comes out hence shown.